Okay, here we go. Okay, no one talk now. Okay, the instructions are exactly the same as the above. It says use limits to analyze the continuity. One thing we are going to do different today is to save a little writing. I hate to ask you to do too much writing. I'm trying to find that right balance of just enough that you remember but not get tired of it. We need to find the limit of this function. That's how we analyze the continuity. On the buff packet, I would have had you write the limit. So you can go ahead and write this. As x approaches 0, but we would have started from the left, like so, of f of x. That's how we would have begun, and I probably wouldn't have put that quite so high. But we would have gone the limit as x approaches 0 from the left of f of x. Okay, bit of a shortcut. About 99% of the time, if you are finding the limit and you're not dealing with a graph or a piecewise function, that's what you had in the buff, it's a little bit easier to try and find the left and right limits simultaneously. It saves quite a bit of writing. You write half as much because you don't have to write all the same limits again. So we're going to put a little plus here to indicate that we are trying to find the left and the right limit at the same time. We're just trying to save a little writing so we don't have to write both. Now, to be honest, that is illegal notation. So you're writing it in your notes to help you get used to the idea, but eventually we'll transition. We won't write it anymore. We'll just remember it. Does that make sense? Okay. It's just to save having to write, basically twice as much information. So we'll just start with that. Okay. It's critical that you always have an equal sign where an equal is appropriate. Equal is appropriate at this moment because we're going to find the limit of f, but we're going to do it using that formula. So this limit is going to equal this other limit. We're going to try and find the left and right at the same time. And now we're just going to pause for a second while we think. Brand new flashcard. So you need to make a card. On the front of the card, I would simply write the words, how to find a limit. So on the front of the card, write how to find a limit. So front of the card, write how to find a limit. Back of the card, write these 4 items. So get that done. While you're doing that, I'll refill 2 flashcard trays. Okay, pretty close. First one on the list says, we're trying to find a limit. We first check, it says if. So you check to see, are they asking you to find a limit that involves x approaching? Here it says positive infinity. The idea applies if it were negative infinity, so kind of keep track of that. I probably should change that to say plus or minus. But if we're dealing with a limit where x is approaching infinity, or negative infinity, we're supposed to compare terms that add. We skipped that step for number 21 because we do not have x approaching infinity. We'll talk about that today still, but not for 21. Question? Please.
Sorry.
You're good.
Do you know things looking at it about infinity, or do you just know that?
Gotcha. So in this case, they said analyze the continuity at x equals 0. So from your memory of the buck packet, you're remembering that all of this stuff we're studying right now is all about this list of xy pairs. And because they want us to study what's happening near 0, we're not anywhere near infinity. So just from the instructions, we're not doing a limit as x approaches infinity. We're just doing a limit near 0.
So it would only really be if it said use limits to analyze a continuity of the function f of x at x equals infinity.
So 2 points for, I'm calling you Matilda, sorry. 2 points for Sophia. 2 points for Lily, sorry, Sophia. Perfectly correct idea.
Okay.
That won't happen, to be honest, because infinity isn't a number. Infinity is this idea of x growing forever. So it can't really analyze the continuity since x keeps just getting bigger and bigger. So there'll be other situations where infinity will appear, and I'll explain those in a bit. But your logic was perfect. Like, that's exactly the right logic. Here it says x equals 0, so we're doing a limit near x equals 0. If it said x equal infinity, we'd do a limit near x equal infinity.
Okay.
Anybody else? Solid. All right, so we skip that step. We go to step 2. Step 2 says to factor and divide. Key element, it's and. There's no reason to factor anything if we're not going to be able to divide. So we're trying to find a factor of the numerator that will match a factor of the denominator. For example, right here, let's put an equal right there. This factor will factor again. The other's not really in a productive way. So like we could rewrite this as 1 minus x multiplied by 7x plus 6. And then just so I can pay some extra credit, anyone happen to remember how this can turn into 2 separate factors? Hands up, who remembers? There we go, keep your hands up, just looking for how many can remember how to factor that thing. If your hand is raised, give yourself 2. Let me just tell you how I remember. I have memorized that anytime you have something minus something, so this little rule that I'm using works for 1 minus x as well. I don't factor it because it's not productive, but I could. Something minus something always factors into the square root of the first term, which is 2. Subtract the square root of the second term, which would be x, and then you write down what's called the conjugate. So 2 plus x. So that does factor. Questions on that? Okay, now that factoring wasn't useful, so there was no reason to do it. I just wanted to illustrate a point. I'm trying to factor and divide. There is no 2 minus x or 2 plus x factor in the numerator, so factoring didn't help. So you don't want to factor unless you're going to end up with a matching factor. Any questions about that? So keep going. So that was kind of a useless step. We are not able to do any factoring that would lead to division, so let's keep going. We're supposed to check the left and right limits. We kind of knew that because we put this little symbol to remind us that we're checking the left and right limits. I write down an F here, that's what we're studying. So now it's really no more complicated than try and compute what result you're going to get, not when you have x equals 0, but when you have x equal, and I should put this table on the main board because that will not show up in the video. So I make a little, this is just in my head, or you can write it down if it helps. But in my head I'm thinking, okay, I've got a set of xy pairs, I'm not concerned with what happens at x equals 0. I am trying to figure out what happens for something kind of like this or something kind of like this. I want to find the y coordinate here and the y coordinate here. Questions? So I don't really have any option other than just to try. So we'll get some people to help me. I'm just going to call you out by name. So Massimo, if you took 1 subtract, remember we're trying to do this at the same time, something like this or something like this, what would you pretty much expect this to become? You don't have to be exact, you just have to be close. Like what will that become close to equaling?
If I plug 0 in?
You're not plugging in 0, remember, because you can't.
Oh, it'd be.
So you're going to plug in like this number or this number.
It would be.
Really close to it.
Yeah, it'd be really close to 1, it'd be 0.999.
All you need is the really close. We don't need to know exactly what we get. We do need to know what we are getting close to. So are you confident that this yellow would be very close to 1? 3 points. So you need me to go through that again. Just wave. Okay, waving. Cool. Go to Ada. So Ada, if I take this value or this value for x and I put them into this, what is that green term going to become close to equaling? And the idea is, you're okay, the idea is to not do the computation, it's just to kind of think generally. So think of it this way, Ada. If I take 7 times like what's 7 times 0 exactly?
0.
Perfect. So if you take 7 times something that's ever so close to equaling 0, does it feel logical that you're still going to be close to 0? Okay, 3 points for Ada. So the green's going to get close to 0. Questions? Okay, we'll go to Ian. So Ian, what would make this then be close to equaling if we're plugging in one of these two for x?
It would just be 6 because the 7.
Very close to 6. Comfortable? So what's the top really close to, Ian, in total?
It's close to like 1 or 0. Yeah.
Be careful. So what was the yellow close to?
It was close to 1.
Perfect. What was the purple close to?
0.
6.
Or 6.
Oh, 6. Yeah, there it goes. So close to 6 times close to 1 would be close to what, Ian?
6.
6. So the top is very close to 6. 3 points for Ian. Questions? Bothered by anything? Awesome. We'll go to Adam Thomas. So Adam, what's this red item going to get close to equaling?
It's going to be close to 4.
Nice, close to 4, 3 points. You need me to go through it again. Well, we'll go over to Tegan. So Tegan, what will this brown item be close to equaling?
Really close to 3.
Perfect. So what's the bottom going to be close to, Tegan?
12.
12. So this is really close to this. That's a valid answer. Or we could say 1/2 reduced, 3 points for Tegan. So it's true for either case. So we have found the left-right limits of this function. As x gets close to 0, the y-coordinate of this function gets very, very close to 1/2. And you pretty much do it all in your head. There's not a whole lot of work to show. You're just getting it done. So, yeah, please, Josh.
We missed out, got close to 12. Wouldn't the 5 be canceled out?
So, are you comfortable that the red factor is being multiplied by the brown factor?
Yeah.
Awesome. So we got to look at the factors first. So, what will the brown end up
Oh, it's
being?
3 times 4?
Does that make sense?
Yeah.
The answer, you good?
Yeah.
3 points for asking. Anybody else? Yeah, please.
I'm just wondering, since like one of them's negative 0.001 and one's 0.001, would that affect the answer? Like, would one still be negative?
It can. It didn't in this case, but let's step through it to make sure we know why. Because it can in other cases. So if you go here, Massimo, 1 subtract a negative that's really, 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 really small, what's it going to get close to? So do it.
Still 1. It's
Still 1. Does that make sense? Still 1. does it matter whether the x is positive or negative? Will it remain 1? Yeah, because you're subtracting. So that's going to be positive. This one, the 7 will change. The 7 times a negative would be negative. 7 times this would be positive. But it's very, very small compared to the 6. So the 6 dominates. The negative didn't matter in this case. Is that good enough? Yeah. 2 more. Awesome. Cool. Let's keep going. That's it. We found the limit. We're supposed to analyze the continuity. Whole class, who remembers what you must do next now if you're really analyzing the continuity? If you forget this part, you lose some points. So, hands up. What do we do? Hands up. We found the limit. We know that the left-right limit is 1/2. So we really know that the overall limit is 1/2. The overall is completely based on the left and the right. We're not done analyzing the continuity. There we go. Let's go over here to, if your hand is raised 1, we'll try Zach Campbell.
Do you have to plug in half of the zeros?
Now I need to go find exactly what is happening for an x value of precisely 0. So, Zach Campbell, when x is exactly 0, what value of y coordinate does this function have? Take your time, just look at that.
It's still 1/2.
Still 1/2. So f of 0 is equal to 1/2. 3 points for Zach. So, questions, please, Vivian.
Could you go through how I have to see this?
Uh-huh. So, this is the formula for how we find all of these XY pairs. Comfortable with that? Awesome. Now it's easier. We don't have to do this close business. We just plug in 0. So if I put a 0 here, 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 and here, what will the yellow equal, Vivian? Perfect. How about the purple? Perfect. So the top would be perfect. Good with that. Then on the bottom, what's the red? So the red is 4, and then the brown would be, do you see it now? Good question. 3 points for Vivian. Please, Bridget.
On the limit, should we say that it's approximately 1/2 or should it actually?
2 points. Great question. If I were trying to plot actual y coordinates for this x, the y coordinate does not equal 1/2. It's simply very close. Same thing here. For this x, the y coordinate does not equal 1/2. It's simply very close. However, the answer to any limit question is always, what are we getting close to? So it actually is precisely equal. Does that make sense, Bridget? That's a good question. What else? Solid. We got one more thing to do. Based on what we did on the buff packet, we go, Adam.
It's a question.
No, please talk to me.
The hospitals rule.
Oh, so it's a French person's name. I believe it does mean the hospital.
I did write hospital also.
I think that's what it means in French. Anyone
I wrote
speak?
hospital.
Anyone speak any amount of French in the room? So I was told it's like l'hôpital. Does that seem about right? H is silent, so l'hôpital. Okay.
Yeah, I wrote hospital.
I think it means the hospital. Yes, no, maybe.
Yeah, I knew it was.
We'll go with that. Anyway, hey, listen. L'Hôpital's rule is something we'll actually learn in like February. So for now, I just have you add it to the card so you don't forget that that's going to come. Right now, you never go to step 4, but eventually that will be part of the sequence of thoughts. Points for Christian for helping us with French. Something else has to be done here. Who knows? There we go. Your hand is raised. Give yourself 2. We'll go to Kara.
We need to write our therefore sentence.
Right. So what's the therefore in this case, Kara?
Therefore, because limit f of x, or x going to 0 is 1/2 and f of 0 is 1/2, but it's continuous at x equals 0.
Perfectly said. Take it for that. That was, like, you get every detail, which is the whole idea. On the AP test, they're pretty picky. Nicely done.
Thank you.
Outstanding. If you need me to write it, wave, otherwise I think you've heard it. No one's waving, I won't worry about writing it out. Guess we can cheat and put the answers. I didn't put the answers in this one. There you go.
I said bang, bang, bang.
Bang, bang, bang. All right.
And then you said there you go, which is basically
There
the
you go.
sound of sound.
That's how you say, in Portuguese, that's how you say, like, it's a standard greeting, at least I was learned like 40 years ago.
Saying there you go.
No, bang, bang, bang. Not exactly that close. In Portuguese,
Sounds
people
like
say,
weird.
como vai? Like, how's it going? You say, tudo bang. Sorry, bang, bang. Never mind.
Too bang, bang, bang.
Tudo bang. Just means total, everything is well.
Everything's good. I like that.
Okay.
I'm
Moving
gonna start saying
on.
it.
Well, Spanish up here and Portuguese bang.
Yeah.
Okay.
Simona.
Next thing, let's stop the video since we, any questions here before I stop the video? Perfect. So now we have another video added to the collection to help you, so
I'll score.
as soon as I can find the stop button.